This is day 6 of Unit 7. We started today with a warm-up, so pause the video, try the warm-up, and then play to check your answers. So number 1, factoring. You first need to figure out the GCF there. So between 2 and 6, that's a 2. Between x to the 5th and x to the 4th, that's an x to the 4th. Between y cubed and y to the 5th, that's a y cubed. And between a to the 10th and a to the 5th, that's an a to the 5th. So then 2 times 3 is 6. X to the 4th times x is x to the 5th. Y cubed times 1 is y cubed. A to the 5th times a to the 5th is a to the 10th. Then minus sign. The 2's already there. The x to the 4th's already there. The y cubed, I need a y to the 5th, so that's y squared. And a to the 5th I already have. So now I'm checking that. That looks like that's not difference of cubes or squares, so that means I'm finished. Number 2, part A. Simplifying square root of 32. Well, 16 times 2 is 32, so 4 root 2. X to the 7 halves 7 divided by 2, so that's a decimal, which means I need to break that up into x to the 6th and x. Same thing with the 3 halves. I need to break that up into y squared and y. And a to the 6, 6 divided by 2 is 3, so a cubed. That's a whole number, and it's odd coming from an even root, so I need absolute value around that. So now let me just put this all together here. So I have a 4. Coming from the x to the 6, I have an x cubed. No absolute value with that. Coming from the y squared, I have a y. And then I have the absolute value of a cubed. And then I have my square root of 2. And then x is still there, and y is still there underneath the square root. And that is my final answer. Letter B. 64 to the negative 5/6. Well, that's 1 over 64 to the positive 5/6. 5/6 is the 6th root of 64 to the 5th. And the 6th root of 64 is 2, and 2 to the 5th is 32. So 1 over 32 is my answer. Okay, so today we first did just a couple problems like these that are just Algebra 1 review. So just multiplying here, so I know distributive property. So negative 2 times root 5 times root 5. Well, root 5 times root 5 is 5. 5 times negative 2 is negative 10. Next, negative 2 times root 5 times root 2. Well, root 5 times root 2 is root 10, so negative 2 root 10. Negative 10 minus that. Those are not like terms, therefore I cannot combine them. Next, 2 binomials being multiplied. We know either first, outer, inner, last, or make a generic rectangle. So first, 3 times root 2 times root 2. Root 2 times root 2 is 2. 3 times 2 is 6. Outer, 5 times root 2. Inner, 3 times 3 root 2. 3 times 3 is 9. So 9 root 2. And last, 3 times 5, 15. So 6 and 15 add to 21, and the 5 root 2 and the 9 root 2 add to 14 root 2. They're not like terms, therefore that's my answer. Okay. Second part of the lesson today, we looked at graphing square roots. So we'll start with the most basic square root equation, which is y equals the square root of x, and we're going to graph that. And we always, of course, when we don't know what a graph looks like, we start with a table. So we talked about in class that I can't input negative values for x here because then I'd have square root of a negative. And we know, of course, that means they would be imaginary numbers. And I can't plot imaginary numbers on a real coordinate plane. So I'm going to start with 0 because I can't use any negatives. So the square root of 0 is 0. So make yourself a coordinate plane and then plot 0, 0. So 1 I can put in because that I can take the square root of easily. 1, 1. And then I'm not going to pick just every x value. I'm going to pick ones, I'm going to be smart about the ones I pick. 4 would be nice because that's a perfect square and I can easily take the square root. So 4, 2. So next, the next perfect square is 9. The square root of 9 is 3. So 9, 3, I'm going to plot that. Okay, now we have enough points that we can see the shape of the graph is a curve starting here and continuing. If I kept going, it would continue to rise. So I'm going to put an arrow there so that I can see that that's the shape of the square root graph. This point right here is called the vertex. We're going to label it 0, 0 because it's important. So if you look at that square root graph, it kind of looks like half of a parabola on its side. That's actually really what it is. It's half of a parabola on its side. So that's what we are talking about when we're looking at a square root graph. So, and also just to note, because that curve is increasing, it's getting higher and higher, there's no asymptote there. It's not leveling off like there would be if there was an asymptote. Okay, so this is the most basic graph, and with every graph we've studied this year, we then looked at the translations and the transformations, and we looked at the equation with involving the general equation that involves the a, the h, and the k. For square root graphs, that equation is a times the square root of x minus h plus k. And that hopefully is not a big surprise to you. That's very similar to all of the other equations we've looked at. X minus h and plus k on the end and the a in the front of whatever it is we have, in this case the square root. So that is the general equation for a square root graph where hk is the vertex. Okay, so now we're going to use that information to graph this one. So you'll need another coordinate plane, copy the equation. So looking at the equation, I can see that plus 2 means it's going to be shifted up 2. And because it's shifted up 2, the original vertex was 0, 0. So 0, 0 up 2 is 0, 2. So I'm going to put that in table and I'm going to plot it. So I'm going to pick some values, again, that I can very easily take the square root of. So 1 sounds good. The square root of 1 is 1 plus 2 is 3. 1, 3 right there. Now, you need the vertex. When you're graphing square root graphs, you need the vertex and then 2 other points. So I need one more point here because I already have the vertex and 1 point. I need a second point. That's a point besides the vertex. When you're picking, we could very easily pick 4, but I always try and get a couple points that are spread out, not right beside one another. So let's pick 9 rather than 4. So the square root of 9 is 3. 3 plus 2 is 5. So 9, 5 right there. Now I have plenty of points that I can sketch my curve and then just label 0, 2 is the vertex. Next one, we graph this, and same thing, we want to first think about what would the shifts be and what would the vertex be. So we know plus 2 is left 2, and we know minus 1 is down 1. So the vertex would be negative 2, negative 1. Actually, I'm going to put that in a table. So negative 2, negative 1 because of left 2 and down 1. So negative 2, negative 1, looks like I already had a point there for the vertex. Now, we know that 3, because 3 is the a value, that's going to be a vertical stretch. So this square root graph is just going to appear a little bit longer or stretched out when we graph it. So again, thinking of values that I could input for x. So now this might take a little bit of thought there, because I want to have, after I add 2 to whatever value I pick for x, I want it to be a perfect square. So values that I could pick, something like negative 1, because 2 minus 1 is 1, the square root of 1 is 1, 1 times 3 is 3, and 3 minus 1 is 2. So negative 1, 2 would be a point that I could plot right there. And I'm going to try and get another one a little bit further down. So let's see, if I had 9, I could take the square root of that. So 7. So 7 plus 2 is 9. The square root of 9 is 3. 3 times 3 is 9, and 9 minus 1 is 8. So 7, 8. Right there. Now I have certainly enough points that I can draw my graph. And again, just label the vertex negative 2, negative 1. Okay, and that does look like we expected. It looks to be vertically stretched from the original graph. Okay, so homework for tonight, pages 34 and 35, and page 30, problems 67 to 77 odds. Next week you'll have a quiz on Thursday, and remember you could have another exponent timed quiz anytime, so keep practicing those and get ready for another exponent timed quiz.